Hi there. Welcome to Xamarin University. In this short video, I want to show you how to take advantage of custom renderers in Xamarin.Forms. Specifically, how you can add new properties to a Xamarin.Forms control and then utilize those properties in a platform-specific fashion when you're rendering on iOS, Android, or Windows Phone. The same techniques we use here are also used when defining your own custom controls. However, we're going to limit our exploration to enhancing an existing control which is already there. Let's go ahead and get started by creating a new project. I'm in Xamarin Studio on the Mac, and I'm going to go ahead and go to the Forms section here in my New Solution dialog, and I'm going to create a new Universal Xamarin.Forms project, Portable Class Library version. I'm going to put it here on my desktop, and I'm just going to call this Custom Renderer. You can also use Visual Studio on Windows to accomplish the same thing. In this particular case, you can see that I got both an Android and iOS project. If I were running on Visual Studio, I would also see a Windows Phone project here as well, but it's only supported on Windows with Visual Studio. Now to start out with, we're going to go ahead and add some code into our Portable Class Library project here. This is the one that's going to be shared across all three of our platforms. And what I'd like to do is I'd like to go ahead and derive a new class from an existing control that's in the framework and add some new properties. I'm going to choose a very simple control, the box view. One question that I often get about box view is, can you create rectangles that are rounded? And the answer is, not with the existing implementation. And that's where a custom renderer can actually add value. And so let's go ahead and add into our project a new source file called roundedboxview.cs. And in roundedboxview, what we're going to do is we're going to derive from the existing boxview class. And I'm just going to add some new properties to it. And so one property that I'm going to want is a corner radius property. Now, you have two choices when you're creating properties for controls in Xamarin.Forms. You can use traditional properties like this, where I would say something like corner radius get set. This does work, and you can certainly use this style. However, this doesn't support some of the more advanced features of Xamarin.Forms, in particular data binding. Data binding is a technology that allows us to tie properties that are on our user interface elements to things that are in our models that are representing those, particularly with architectures like MVVM, where I create view models to actually hold my data and provide my behavior. And so if you'd like to take advantage of data binding, then we'll need to create this property in a slightly different way. And so I'm going to create something called a bindable property. Now I have a nice code snippet here that allows me to quickly create these. And so notice that it has two pieces to it. First, we define the property itself, which has a name. We'll call this corner radius. It has an owner, rounded box view, and it has a type. We'll make that a double. And so this is a public static field that actually just describes the property itself. And so notice it's held in a property called corner radius property, and it's created through a static method called bindableproperty.create. This is a generic method that takes the owner, the type of the property, and then a expression identifying the actual real property that's going to be used to access this, as well as the default value for the property itself. And there are a couple other overrides for this that allow you to wire up a property change notification so that you can tell when this property has been altered and things like that. The second part of this is an actual instance field of type double, which is called corner radius, but notice the getter and setter are actually relying on base methods get value and set value. These methods come from a base class called bindable object, and all of our Xamarin.Forms controls, such as box view, all ultimately derive from bindable object. And so if you're going to use bindable properties, you have to derive from bindable object. Now in this particular case, notice that we have a getter that calls get value and it passes in the corner radius property, and a setter that calls set value that passes in the corner radius property, this field, and then the value that we'd like to set it to. And that's all we have to do. The system will take care of the actual storage of the field, and it will verify that the field is the right type and all of that sort of thing. Let's put one more property in here. And so let's make this a outline color. Again, my owner is going to be a rounded box view, and the type is going to be color. You got to make sure to spell that correctly so you can see that we now have both of our properties here. Now, with this in place, I now have a box view that describes a corner radius as well as an outline color so that I can get both an outline on the object, but also get it to be rounded. So let's go ahead and use this. Let's go over to our app.cs where we're creating our content page, and I'm going to remove this code here, and instead I'm going to replace this with a new object that I'm going to call main page. And so let's just go ahead and create that. I'm going to derive this main page from content page, and then I'm going to put a constructor on it where I then describe what my UI is going to look like. And so first let's create a stack layout. Let's set a couple properties on our stack layout. In particular, I want to go ahead and set spacing. That'll put some padding around the elements themselves. And then let's go ahead and set padding. So padding will allow us to kind of inset our content from the edge of the stack layout so that in iOS, for example, we can make sure to push the content down below the carrier bar. And so we're going to set this to a new thickness. I'm going to set the left to 20. The top is where I want to actually be slightly different for iOS versus my other platforms. And so I'm going to use the device on platform helper where I can basically supply 20 for iOS but 0 for my other two platforms. And so therefore they'll sit right at the top of their frame, which is below the carrier bar in the case of Android. And of course in Windows Phone, it takes up the whole screen. And then for my right side, let's go ahead and set that to 20. And then for my bottom, let's go ahead and set that to 5. Then let's go ahead and create one of our new rounded box views. And so we'll call this rounded box view. It is a new rounded box view. We can set the color, which will fill the shape. Let's set that to color red. Let's set the outline color to color blue. Let's set the corner radius to 20. And let's just put a couple of other properties on here. In particular, for layout purposes, let's set our width request to 100 and our height request to 100, just so we get 100 by 100 square. And then let's go ahead and center it horizontally. And so we'll set the horizontal options to be a new layout options center. Put our semicolon on that, and let's go ahead and add it into our layout. And finally, let's go ahead and set our content to this stack layout. Now, I'm going to go ahead and set the iOS project as my startup. Since I'm on a Mac here on Xamarin Studio, I'm going to go ahead and run this in iOS just because that's the more natural environment to start with. And let's just see what happens when we just run it with this and we haven't defined anything else. And so here you can see my iOS simulator, and I'm getting a nice box view here. And so the system recognized that my class, even though it was a customized box view, it's still ultimately a box view, and therefore the renderer that got chosen was the box view renderer that comes with the platform. Now, if I had created my own control here where I was simply deriving from view, which is the base class for all of these elements, then if I didn't have a renderer registered for that view type, what I would see is nothing. So the system wouldn't actually render anything there because there isn't a renderer in place. It doesn't throw an exception, but you won't see any output on the native platforms. And so therefore, if I don't create a renderer for a given platform, then I won't see any output on that platform, which kind of makes sense. And so let's go ahead and actually create a renderer for iOS. So let's add a new item. I'm going to name this rounded box renderer.cs. Now I have a couple of choices. I'm going to start with actually deriving from the existing box renderer. Remember that we're deriving from box view, and so it kind of makes sense if we just derive from the existing box view renderer that's already in the system. That's a class called box renderer. And in order to make this work, since this is actually just a shape, what I'm going to override is actually a draw method here. Notice that the draw method gets past a rectangle f. That's because if you look at the rendering architecture that's built into Xamarin.Forms, it actually derives from the existing view architecture of whatever the platform is. And so box renderer, for example, ultimately derives from UI view, which is the base class for all views that are presented in iOS. that means that this draw method is really the UI view draw method. And so when I draw, what I'm going to do is I'm going to end up drawing into my UI view. And so let's go ahead and do that. Now, I obviously need some information inside this draw method. Specifically, I need the information that was contained inside that rounded box view that we created. I need that corner radius, I need that outline color. Turns out it's actually really easy to get a hold of. It gets passed into the renderer as something we call the model. And so I can simply say rounded box view is equal to rounded box view this.model. So this gets set by a method as part of the construction of the renderer, and the model will be whatever the Xamarin.Forms control was that described all of the properties and all the events and things that were being hooked up. And it's our job inside the renderer to then present those specific for the platform, and also to provide the tie for any native events that are happening on the platform side to push them back up into the Xamarin.Forms control model. In this particular case, we don't have any events on the box view, which is why I selected it. It's a very simple construction. So let's go ahead and just draw this using core graphics. And so the first thing I'm going to do is create a context. And so we'll go to UI graphics and say get current context. And then inside this using statement, we'll go ahead and draw out our rounded rectangle. And so let's go ahead and set our fill color. That's going to be the color that we've actually selected on this rounded box view. Now, what set fill color wants is a CG color, a core graphics color. And the color that we're using here is the Xamarin.Forms color. But it turns out that in each one of the platform DLLs, you'll find a series of extension methods that allow us to convert the Xamarin.Forms kind of objects into platform objects. And in this case, you can see I have a 2CG color extension method, as well as a 2UI color. So this is UI kits representation of a color, and this is core graphics representation of a color. So we'll go ahead and set our fill color. Let's go ahead and also set our stroke color. That's going to come from our outline color that we created. And then let's go ahead and set our line width. And so I'm going to just assume a standard line width here, but here I might want to create a property in my rounded box view control that would represent whatever the border width would be. So I might call it outline width or outline size or something like that, and then I would be able to read that property here. I'm just going to go ahead and hard code it to 5 in this particular case. Then let's go ahead and pick up our bounds. Now what I want to do is I want to basically create a rounded rectangle within this bounds, and I'm going to use one of the new iOS 7 features which is on the CG path class called FromRoundedRec. It's actually an extension, or rather there was an existing method prior to that in iOS 3 that was on the UI Bezier class. But the first thing I'm going to want to do is go ahead and inset my bounds so that I don't get clipped off. And so let's go ahead and inset it by the stroke size here. And that will then cause my rectangle to be inset by 5 pixels on all sides. And that way when I create my rounded rectangle, it won't get clipped off on the edge. Then I need to go ahead and pick up my radius. Now the radius is obviously going to be the corner radius that we selected here. So we'll say corner radius, but I have to make sure that this radius, first of all, is greater than or equal to 0, and it's less than the height and width divided by 2 of my rectangle. And so if you don't, then iOS will actually throw an exception if you try to use this as a corner radius in the API, and your application will crash. And so let's just go ahead and fit it that way, and we'll just basically say we want it to make sure that it's at least 0, and we also want to make sure that the radius is at least or within height divided by 2 and width divided by 2. And so we'll just use this little bit of math here to kind of make sure that our radius is greater than or equal to 0 and less than the max of either the height divided by 2 or the width divided by 2. Now we can go ahead and create our path. And so we'll go to CG path, and we'll say from rounded rect, we pass in the rectangle that we're looking for here. That's going to be our inset bounds, and then we pass in our radius. That will then create a path that is rounded for us. We can then add that to our context, and then I can go ahead and say draw it. And so we'll go ahead and draw it with both a stroke and a fill. And so I'm going to say go ahead and fill and stroke it. And that should be all we need to do. This in itself, if I were again to run this in iOS, we would see that we still get the normal render for the system, because as of this point, I've not associated this rounded box renderer with my rounded box view class. To do that, I have one more step, which is to apply an attribute here at the assembly level that's called export renderer. So you can see it's right here from Xamarin.Forms, and it takes the type of the Xamarin.Forms control, that would be rounded box view, and it takes the type of the renderer. That would be rounded box renderer. And of course, I'm going to go ahead and add in my namespaces here. And so I'm going to need both the custom view namespace as well as my custom renderer iOS. When Xamarin.Forms initializes, it goes through all of the loaded DLLs and it identifies each one of these export attributes. And then it basically just creates a dictionary so that when it hits this rounded box view, it knows to use this particular renderer when we're in iOS. Now, again, I want this to be clear that we do this on a platform-by-platform basis. And so I export a different renderer for Android and a different renderer for Windows Phone. And if I don't export a renderer and I'm simply deriving from an existing class that's a Xamarin.Forms control, then it will use the system renderer, which means that in this particular case, my rounded box renderer is only going to be used for iOS. So I can make my control very specific to the platform with this approach. I don't have to create renders for the other platforms if I'm comfortable with the existing renderer that's there. It's a very powerful technique that we have here. But now that I've exported this, we should be able to run our application. So it'll build and go ahead and run inside of our simulator here. And now you can see I get nice rounded corners with a blue stroke and a red fill. Now let's go ahead and add into our app here one more thing. Let's go ahead and put into this a label first. So we'll say layout, children, add, new label. Let's just set the text to be corner radius, and let's go ahead and set the font to be font, bold, system of size, let's say 24. And then let's put in here a slider. And so I'm just going to create a new slider. We'll set the minimum to 0, the maximum to, say, 100, and the value, the current value, to 0. And then let's go ahead and hook up an event to it for the value changed event. And when the value changes, I'm going to go to this box view, and I'm going to say the corner radius is equal to the slider value. And so we'll just adjust the corner radius based upon that slider changing. And then let's add this to our children collection. So let's try this again. So now we're going to be able to adjust that corner radius at runtime with this slider. So now I have my slider. As I slide it, notice that my corner radius isn't changing. Now this shows an important point, which is what we're changing here is the rounded box view's representation of this property, this corner radius. But rounded box render doesn't have any idea that the fact that that property changes should cause the draw to be recalled. In other words, there's no relationship between that property and the rendering of this particular object. And so to make that work, we actually have to override another method here called onHandlePropertyChanged. And this does exactly what you think it does. It hooks into the iNotifyPropertyChanged infrastructure and into the binding infrastructure, and when it sees properties change, this method gets called. And we're going to go ahead and pass it along to the base because we've derived from box renderer here, and therefore that will go ahead and take care of the color property and background color and things like that. And what we now want to look for is just our specific properties. And the way we do that is we go to the property name and we say, is it equal to rounded box view? And let's pick up our outline color property. And again, it also has a property name value on this. And so we can test for that. Or if it's equal to rounded box view corner radius property name. If either one of these two properties change, then I want to go ahead and make sure to re-render this shape. And so we'll just call set needs display. And so remember, this is an iOS UI view, meaning I have access to all the normal UI view stuff. And so I call set needs display in order to force this to re-render. Now when I run it, now as I adjust this, you can see that my corner radius is changing up to the center point where it becomes a circle. And at that point, we don't change any further. That's our math kind of limiting that. And again, if it goes beyond that, CG path from rounded rec actually throws an exception. So we don't ever want it to get past that. But you can see it is working and it is redrawing. Now, one other thing that I want to show you here, and that is we derived from box render, and this is just a simple shape that's being drawn. But what if this were actually a control? So as an example, keep in mind that we could have actually done this a different way. Let me just comment this out. I'm going to copy it first and then comment this out. I'll leave that implementation in place. And instead of box render, I'm going to use a different renderer base class, which is called native renderer. Native renderer is actually the class that most of the controls in Xamarin.Forms use for their rendering. And what it does is it allows us to create a new control in whatever that platform's architecture is, and then assign it, and then it uses that control as part of its native rendering process. So as an example, when we create a label in Xamarin.Forms, the native renderer for that actually creates a UI label to represent whatever the text is, and it sets the appropriate properties and everything else. And so in this particular case, we're not going to override draw because we won't need draw at this point. We'll go ahead and override handle property change, but we're going to do something slightly different with it. And so here's how this would work. I'm instead going to override on model set. So this is a method that gets called whenever the model, in other words, our Xamarin.Forms control, is being associated with the renderer. And we're going to go ahead and call the base class because we want to let it do all of its setup. But then we're going to go ahead and create a new UI view that actually has all of the characteristics that we want, all right? Because we can actually use the CA layer to be able to create rounded corners. And so we're going to say view is equal to new UI view, and I'm going to go ahead and pass into this rectangle F empty. So we're just going to go ahead and assign it to an empty rectangle here. And once we've done that, then we can sort of set up some of our values. So for instance, I can set the background color for this UI view to be our model, and then whatever the outline color is. Let me just go steal one line of code up here. So let me grab that line of code because I obviously want all of my custom properties here. And so after our model's been set, we can then go ahead and cast this dot model. We could, of course, have cast this inbound property as well. It will be a rounded box view. And so here we'll just say rounded box view, and this would be color. And in this case, I actually want a UI kit color because we're setting the background color here. And then let's go ahead and assign our layer properties. And so in this particular case, I'm going to go ahead and set the corner radius for the layer to be the corner radius from the rounded box view. And I'm going to go ahead and set the border color, and that'll be the outline color. And this is actually a CG color in this case. And then I also want to set the border width. And again, I'm just going to hard code this, but remember, this probably should have been a property in our model. Now, once I've got this view, all I have to do is then call set native control. I pass in the view, and now this becomes the representation for my Xamarin.Forms rounded box view. By doing this, that then sets everything up the way it's supposed to be. Now, the other thing I'm going to want to do here is when either one of these properties change, I now want to affect whatever that control is. And so here's how we do it. We already have a UI view, and it turns out there's a property on here that's just called control, and it is a UI view. And so we can come in here and we can say if it's the outline color, then set the control layer border color to be the new outline color. And so that would be our model view. So that would be our rounded box view rather. So let's go grab that. So I need this here as well. And then we can just say RBV outline color to CG color. And if it's the corner radius, we don't need to do a set needs display anymore because now we're not rendering it in the same way. Then we just do a control.layer corner radius is equal to float RBV corner radius. So now we're just going to adjust the properties that are set on this native control that we've created. And so now this will be our rounded box render. Let's run this and see how it works. So notice I get exactly the same effect, and in fact this one actually even allows me to go beyond that value, and then it becomes kind of a diamond shape. And so I even have a slightly different behavior here because it's not restricting it. All right, but the point of this is you have a lot of freedom in terms of being able to create these renders, and you can create very customized renders, or you can customize an existing render to just extend its behavior or slightly change the way it works. So this is a very powerful mechanism in terms of being able to kind of create very customized experiences for each one of your platforms while still describing your UI with a set of cross-platform classes that you're then sharing between each one of those platform assemblies. To create the visualization for Android and Windows Phone, we would follow the exact same set of steps we did for iOS. We would utilize our new rounded box view class, which is defined in the portable class library, or it could be defined in our shared project style as well. We would then create a new view renderer in the Android project. We could either derive from the box view renderer like we did in iOS, or choose a different base class. For example, the view renderer base class is useful for views which are completely implemented in your rendering code. And the native renderer base class is a good choice if you're creating controls native to the platform. It essentially allows you to create some native control and then assign it to a property of the native renderer, and then it will present that in place of any drawing that you might have done. Finally, we add the export renderer attribute at the assembly level to associate the control defined in our shared code with the renderer on the platform. When Xamarin.Forms initializes, it scans all the loaded assemblies and finds all the export attributes and creates an internal mapping of Xamarin.Forms controls to the native renderings. One important note to make about this initialization is it will only look in assemblies which are currently loaded into memory. That means if you're trying to create shareable component libraries, you will need to make sure to call something in that library prior to calling the forms init method, so the assembly is loaded into memory. Just adding it to the project won't be sufficient to load the assembly. You have to use a type directly in your code to load it. I hope you've enjoyed this short webinar on customizing renderers for controls in Xamarin.Forms. This is just an example of some of the types of content you'll find in Xamarin University. When you enroll, you get access to a whole suite of advanced sessions about Xamarin technologies, which are available in both live and recorded form. You can register for one-on-one sessions with instructors to talk about architecture and your specific development goals, and you have the opportunity to take the certification exam and become a Xamarin certified mobile developer. To get more information or to enroll in Xamarin University, just visit the link on the slide. Thanks for watching, and we hope to see you in a class soon.